Welcome to Bangladesh. Our Earth is unique, not only in the solar system, but as far as we know, in the entire universe. It is the only planet where the existence of life has been confirmed. However, this fragile cradle of life has witnessed geological events and catastrophic accidents in the past that were nothing short of an apocalypse. Because of these events, life on Earth has always been vulnerable. Tsunamis and earthquakes have wreaked havoc at various times, claiming millions of human and animal lives. Furthermore, these events have occasionally caused massive shifts in the Earth's geography. At times, the planet's rotational speed fluctuated. At others, rivers reversed their flow. The Earth's mass redistributed, and even the magnetic north and south poles have shifted positions. Usually, geological processes are incredibly slow. It takes countless years for rivers to dry up, fertile lands to turn into deserts, or glaciers to melt away. However, 66 million years ago, an event occurred that changed the fate of the planet in a single day. Known in history as the Cretaceous Paleogene (KPG) extinction event, this catastrophe shook the Earth to its core. Thousands of animal and plant species went extinct, sunlight failed to reach the surface for years, and a night-like darkness swallowed the globe. Why did this happen? How did this long, dark night end, and how did a new dawn of life emerge? Let's explore the answers to these questions. As mentioned, this terrifying event is scientifically known as the Cretaceous Paleogene, formerly KT extinction. Geologists divide Earth's history into a geological timescale. The division between the Cretaceous period and the Paleogene period is defined by this mass extinction event that occurred approximately 66 million years ago. In the blink of an eye, geologically speaking, 75% of all plant and animal species were wiped from existence, creating a massive biotic crisis. But how? According to experts, the cause was a massive asteroid originating from the asteroid belt located between Mars and Jupiter. Due to a gravitational perturbation caused by Jupiter, often referred to as a resonance gap, this asteroid was nudged out of its stable orbit. Once it escaped Jupiter's gravitational binding, its new trajectory intersected with Earth's orbit. Earth's gravity acted as a resultant force, pulling the rock closer. As it approached, Earth's gravitational pull accelerated the object, increasing its speed significantly. Eventually, this collision became inevitable. The asteroid slammed into the Yucatan Peninsula, modern-day Mexico. The impact created a crater approximately 20 kilometers deep and 180 kilometers in diameter. This is known as the Chicxulub crater, named after a nearby town in the Gulf of Mexico. Today, part of this crater lies on land, while the majority is submerged under the ocean. You might wonder, if the crater is so big, why can't we see it in photos? Where is the asteroid now? To answer this, we must look at the physics of the crash. The asteroid was traveling at a staggering speed of at least 45,000 miles per hour, approximately 12 miles per second. To put this in perspective, this is many times faster than an F-16 fighter jet. The asteroid was 10 to 15 kilometers wide and weighed an estimated 2 trillion metric tons, equivalent to the weight of 4 million Burj Khalifa buildings combined. Upon impact, the asteroid was completely fragmented and vaporized. The collision released energy estimated at millions, some say billions of terajoules. For comparison, the atomic bomb dropped on Hiroshima in 1945 released about 60 terajoules. This impact was equivalent to millions of atomic bombs exploding simultaneously. The vaporized asteroid and Earth's crust were blasted into the atmosphere as hot dust and debris. Some of this material was ejected out of the atmosphere into the solar system, but a vast amount fell back to Earth. This created a rain of hot dust, molten glass beads called tektites, that set the world on fire. Global incineration. Within thousands of kilometers of the impact, animals and plants were instantly incinerated, Seismic activity. The impact triggered earthquakes of magnitude 9, 10, and 11, shaking the planet more violently than any recorded modern earthquake. Tsunamis. Massive mega-tsunamis were generated. Initial waves were estimated to be 1,500 meters, 1.5 kilometers high, eventually settling into 100-meter waves that devastated coastlines globally. Volcanism. The seismic shockwaves triggered volcanic eruptions, causing lava to flow from mountains and fissures. Almost every four-legged animal weighing more than 25 kilograms died. The only survivors were those small enough to burrow underground or dive deep into the oceans. The disaster didn't end with the explosion. The immediate fire was followed by a deadly cold known as an impact winter or nuclear winter. Approximately 25 trillion metric tons of dust, soot, and sulfur were injected into the atmosphere. While heavier debris fell back down, fine particles stayed aloft, spreading across the globe within weeks and completely blocking the sun. NASA and other space agencies track thousands of near-Earth objects, NEOs. There are hundreds of asteroids larger than 1 kilometer and thousands of smaller ones. Currently, scientists are not just watching, they are preparing. Added information: NASA recently conducted the DART mission, Double Asteroid Redirection Test, where a spacecraft intentionally crashed into a small asteroid, Dimorphos, to change its trajectory. This was a success, proving that we can potentially deflect a planet-killer asteroid if we detect it early enough. While humans cannot guarantee 100% safety, we are the first species in Earth's history capable of predicting and potentially preventing our own extinction from the cosmos.